I'm going to show how to take a simple state diagram and convert it to JavaScript automatically. I'm going to use ohm.js. We're going to do it very simply. At the moment, we're just going to do this we're going to write it out as a text program, and then we're going to use ohm.js, a peg parser, to convert it into JavaScript. What I've got is a name field, inputs field, outputs field, and the main body of the machine, describing the two states. We describe the two states off and on, and what to do when we enter the off state, and what transitions to look out for in the off state. The on state, what transitions to do, what code to run when entering. Step one is to mock up the language in some editor. I show a prototype language on the left here that represents most of this diagram. It's got a name field, an inputs field, an outputs field, and the main body of the machine. The body of the machine shows the various states, gives their names, gives code as strings, what to do when that state is entered, and what transitions to watch for, and which states to go to. So in this particular case, we go from, if we're in the state off, and we see an input coming in on the _in pin, this pin over here. Reading the body of this machine, we see that it's called toggle. It has two states, state off and state on. When we enter the state off, we execute this entry code. It's signified by a string at the moment. We can do something more fancy later. And the transitions are started by the keyword on. So when we see an input, when we're in the state off and we see an input on the in pin, which is this pin over here, then we transition to the _on state. I've unfortunately used the word _on to mean a state and on to mean the actual transition keyword. If we're in the state on, which is this one over here, as we enter the state, we execute a piece of code, which is signified by this string. And if we're in the state on, and we see an input in, then we fire this transition, and we go to off. And when we go to off, we fire that transition entry. The default state for the machine is the state called off. The next step is to mock up or write the grammar after we've mocked up the language. We can use any editor to write the grammar. Now we've written the first cut of the grammar. I've told you there's errors in it. We're going to find them as we go. I'm going to try to show how this happens. The next step is to actually test the grammar. If you're a diehard, you're going to run the grammar through Yak or Bison or one of those. I tend not to do that. I tend to just grind my way through using the ohm editor. Here's where you can find the ohm editor. I'll try to open that up I'm going to open up a new window, and I'm going to put the ohm editor into it. If I just do ohm editor, I think it comes up as the first hit, and it comes up with whatever I've been working on most recently. Select that with Command A and delete it. Next, we take our grammar and slap it in there. So I'm going to select the whole grammar, copy, go into here, click in there. Now, and I'm going to take a test on this side, on the right-hand side. So this left-hand side is the grammar, this right-hand is the examples, and the bottom is going to show you how it parses. So I'm going to add a new test. I'm going to use this piece of code as the test, and it doesn't seem to be complaining, so it's not actually doing anything. That's because I've done this in JavaScript. So I'll get rid of the JavaScripty stuff. It only knows how to do now. It's giving me an error on line 33 of the grammar, and the double quote, the escaped escapes in JavaScript are not allowed, are not welcome in the OHM grammar itself. So I'll just get rid of those and see what it comes up with. Oh, and I've got, it says capital identifier doesn't exist. And that's because I don't have something called a capital identifier. I call it little name. In OHM, capitals, names with capitals are different than names. In OHM, names with capitals are different from names with lowercase. We're just going to use all lowercase everywhere here. It's saying that state name reference is not defined. Oh, state reference. Okay, so that's just a straight typo. And now it says exit code is not defined. And there's a typo there. That needs to be exit code. What have we got for errors? I don't see any errors here. We'll double click on the test, and then it says it expected a letter. And a letter, in this case, here I've got a capital. Is that the first problem? What's an ID? Is a letter or a digit? A letter. What's a letter? Just for my own purposes, I'm going to first ID is capital A through capital Z, or lowercase a through lowercase z, or the underscore, and follow ID are something that looks like a first ID already. Let's see if I can. ID is first ID followed by follow ID star, and there's another double. There, how's that? Expected a, so the error message is misleading at the moment, probably. And so we need to look for anything prior to this. Do I see anything here? I take this first and follow ID code and move it up here. Checking to see if there's missing quotes anywhere. I don't see that. What? Maybe I'm mixing languages here. How's that? Still not right. Okay, we're finally out of the woods in fixing simple typos. So I'll put back the underscore business. So my problem was that I was mixing, parsing languages. Some language that I use doesn't want the a.z double quoted. Ohm requires a.z to be double quoted. Now we see we're getting errors on the test code, and it's showing that it's a backtracking parser, so when it gets lost, it gets lost. You can come down here and try to see if this gives you any help in trying to figure out what it didn't. Oh, this is the place where I've got the bug where I don't say the word state. Is it part of, yes, it's one of my keywords, but I don't actually use it in the definition of the state. So the problem is that I've forgotten to put in this business. So what I'm saying is that a state is defined by the word state, followed by a colon, followed by one of entry code. I'm looking at this, so I'm here. State definition goes to state definition. It needs to see the word. And because it's backtracking, it may have hit a problem here and backtrack all the way to here and saying it can't match this whole thing. So we can do this in little pieces. I'm gonna, in fact, I'm gonna record this definition so far. Put it here. Go back to that. I'm gonna build it up slowly. I'll take out all of the real stuff and leave only the bits and pieces. So there's no such thing as a port section or machine definition. It doesn't manage and in this case, I've been giving it a test. So if I take the test, I'll take the test and put in a much smaller test. So now I'm going to reduce the test, hopefully, to just a name and a toggle, which is what the grammar says. So it's already failing just on that. It says name, colon, it needs some white space, possible white spaces here. Ohm tries to help you by saying that that it'll get rid of white spaces on you automatically. If we do this, if we make capital letters out of things, put a capital there. What's a name? A name is not a keyword followed by an ID. There. So now what we've got is a very simple test program. The Ohm editor defaults to using the first rule you've defined. You can have any other stuff here, but it'll look at this first rule and then find all the subsequent rules that it needs. So it needs a name section, and name section needs to refer to name. So all this stuff here in between is being ignored. Name needs keyword and it needs ID. Keyword is defined here. So I've just listed all of the keywords that I think are in the mock-up language. an ID is a first character followed by 0 or more follow characters followed by white space, 0 or more white spaces. White spaces are defined down here. Keywords are defined here. ID. Oh, right. Yes. So I've defined the first ID to be big A through big Z, or little a through little z, or underscore. And so this little test program is actually succeeding. If we drill down, we see that it's taken name section. It's lighting up name section up here, and showing that it breaks down into 3 parts: name, colon, and name. And name is a rule, so I can click on it and it'll expand it and tell me what it thought it found here. So the ID was TOGGLE. It's lighting it up here. I can't show this to you reasonably. But if you look where the blue highlighting is, it shows the letters. Each letter, so if the first ID was T, the follow IDs are ogle, follow, 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 and then some white space, and then end, which is a built-in to Ohm.js. Now we'll go to more interesting pieces of test. So I'll grab that, and then I'll make a new test, and I'll do everything up to, but not including the machine section. So now it's failing because the grammar says that a state machine only consists of a name section. So now if I put in an input, I'll make it a capital input section. Oh no, yeah. Section, output section. And it'll say that those aren't defined. No, I've done the wrong ones. I'll leave those alone. So I don't have an input section, so I'll put in input section is input inputs followed by a colon, followed by ID, 1 or more IDs. And then if I do the same for output section is outputs, followed by colon, followed by ID plus. And I'm looking over here, it's saying something's wrong with well, we may need a comma to make all this stuff work. So we're going to say outputs is going to be an ID followed by a comma followed by an ID 0 or more of. And that's still wrong. Output in. Yeah. What have I done wrong here? I'm staring at name section, input section, output section. Because I use capitals here, Ohm.js is skipping white space, or things it calls space. I don't have a rule called space, S-P-A-C-E. So input section is inputs follow. Well, so let's go back to just making a simple test of this. We'll modify the test code, and lo and behold, that works fine. Okay. Now we add the test. Take this same test. and then we'll say outputs is an ID. Oh no, it's going to be a name instead of ID here. Name. That has to be a name. And that has to be a name. And the reason it has to be a name is that the name rule says skip over, don't allow keywords, whereas ID doesn't have that restriction in it. Oh, input section. So an output section. And it finally, now if I put in comma, no, that'll pass. And if I give it comma, new line, no, it'll still pass. So it says comma, no, parses as comma, any number of spaces followed by underscore, no. Now if I don't like languages with commas in them. I'm going to copy that out, create another test, and I'm going to delete the comma business. So now this is a condition that OM.js doesn't handle very well. And it's here that it doesn't handle it. What do I do here? So the problem is that when I capitalize rules, OM.js automatically skips spaces. It has to bump into something that is more significant than a space, like a comma, in its imagination. If I delete commas, it doesn't know what to do without me being more explicit. And I'm trying to put white spaces back in. This is the way one can write any peg grammar. What really should happen is that OM.js should parse all things into tokens first. And I'll show how to do that later. I'm going to try to fix this grammar to allow me to have no commas. And output section, to work with white space, we're going to need to lowercase things for starts. We've got a white space here, and we've got this thing probably consuming white spaces. No, name. So it's got name followed by any number of spaces. Oh, space. I need to use the space plus. Should be parsing that. Then it needs to come to name. Name says don't give me a keyword. Then follow it by an ID. An ID is one of these. White space is 0 or more of, so we don't care. But it's confused. If I put white space back in here, don't let it take care of spaces for me. So it's got to have at least. So what I've written here, I think, or I'm trying to get at, is that there's a name followed by at least one or more white spacey things. And that new line, according to this, new line is one of the possibilities. We can see that the problem has to do with the comma, just by putting a comma business back in. We probably need, we've got this lowercase. That succeeds. If I make it lowercase, then white space becomes significant. So here it's space, oh, white space, maybe we take out the comma business, white space, at least some white space. Expected end of input or new line or T or no, it's failing on. It's showing me that the underscore in no is somehow not recognized. We can test by getting rid of that. That parses fine. I put in a new line, still parses fine. And I put in XYZ, and it fails. Put a white space star here, and it still doesn't work. What's wrong? So it got, no, it does work. I'm sorry. No, it's not working. It's expecting to see an end. It saw a white space there, and then it doesn't see the XYZ. It thinks the XYZ is unrecognizable. And that's what it's saying at the moment. Outputs colon yes. If I expand that, it's got the white space after the yes. That subsumed the white space. So ID has eaten the white space that I needed. That's what's going on, as far as I can tell at the moment. If I remove white space from ID, how does it hurt me? I can try to do that, and now it works fine. I can probably get rid of that, yes. Can I do this? There. And that's working. I'll get rid of this white space. And I'll call that more names. And more names is more name is a white space. There's got to be some white space. More names. I'm going to move the star up to here. More name. Okay, typo. Get rid of the typo. And it's still complaining about that for some reason. Name is yes. More name is failing. And then we put a white space star up here. It still fails. What's going on? I'm digging to see what happens here. So more name is failing on the underscore. So maybe if I get rid, I'll start by getting rid of the underscore. I'll get rid of things I don't need. So it's seeing inputs name doesn't do it. Change that to capitals. Get rid of all the underscores. And now it's unhappy about in. I've taken name. I'll change that to a more name. A name section. Okay. Oh, I see. Okay, so we're going to change everything to lowercase so that it doesn't skip white spaces, and then do the white spaces more explicitly. So I'm going to take all these, turn them to lowercase, so inputs. So let's go back to our earlier test. This test. This fails right away. So we get rid of all this stuff and we just say it goes to a name section. Name section, W space, white space, star, anything is fine. So then we go to the next test with just inputs. That works. So now we should be able to put outputs. We'll do simple outputs first. Just one with no commas. That may, okay, input section WS, output section WS. And an output section is that. So now can I put in a underscore? No. Yes. So now I can take the these things, demote them to more interesting places, to less interesting places. So I put it on here. Let's do it in pieces here. So I'm going to put it here, put it here, and put it here. Then I should be able to wipe out the white spaces, and it's still, I can see that it's working. So it's got successfully found a name, input, and output section. If I say more name W space star, go to here, and that'll fail because we're eating white spaces that we shouldn't be eating. I'll put them back. So that works fine. So if we're if we're trying to parse more than one name, this should be one or more of. And this could be one or more of, and then I could change, and now that's parsing fine. If I capitalize this, and I need to change the name down here. That's not going to work. So if I just say name, that I'm going to edit, it's going to start failing as I edit. Forget this more name stuff. Put the only thing that it needs is a white space there. Get rid of this. And that works fine. So a name, it now knows how to parse names. So what's the next test up? Oh, putting underscores. How about this one? Forget the commas. Well, in fact, if I want to do white space, if I want to make commas white spacey, I just add them to the white space rule, and the problem goes away. So if I can have a language that has commas or doesn't have commas, and it'll parse. I find I've grown up knowing that you don't need commas in languages. That mostly comes from yak-like thinking, LR, generating languages instead of parsing languages. And if you didn't understand the difference between generating and parsing, don't worry about it. It'll come to you later. Or it won't come to you at all. You don't really care. What you really want to do is show how things are to be parsed in sequence. Now we'll go to a more interesting example. I think I had a more interesting example here, and that's failing. For some reason, machine isn't working. It's failing on machine, and that's a keyword. Oh, that's because I haven't told it to look for a machine section. Machine section. And the rule machine section is not declared. I'm going to look down here to see where did I start talking about. I've already forgotten how I was going to define a machine. A machine name is here. Maybe oh, right, I took it out as part of the testing stuff. So I'm going to say a machine section is, I'm going to make it uppercase. Machine section is a header, so we'll start with a header. So we'll start with a simple example. Let's add a new test down here where I only give it the name and the colon. Well, I can give it the name and the colon and the end. Machine section. Everything's lowercase for some reason. I thought I was getting this. I've forgotten which way. Header, followed by a body, followed by a trailer. And a header, a machine header is the word machine, followed by a colon, followed by a name. And a trailer is end followed by machine. So that's not parsing. Oh, it's not machine. I've got that wrong. It's not there. It's here. How's that? So I'm looking at machine section. Let's just do machine section, which is a header. Only a header. Get rid of that business. And this should fail. So let's simplify even further. We'll get rid of toggle. And so it's machine followed by nothing. So expected end of input. So something is still wrong. Name section, input section, output section, machine section, header. Oh, white space stuff. How's that? That works. So now if I go and I try to put in a name here, machine XYZ, that parses. What if I put in a colon? That should not parse. And now it parses. Okay, so name section, input section, output section. I'm collapsing these so I can have a better look at it. We don't really care. So name section, input section, output section, machine section, white space. And that's a whole state machine, yes. So that's, and now can we put in a trailer, end machine. That's not working. End is one of the keywords. Looking at that, just double checking. So when it sees header, it expects a machine, then a name, then a colon. So it appears to get that right. Maybe this will give us some clues as to what's going wrong here. Name section, input section, output section. So it's decided that this part is part of the output section. And there's some funnies going on with our white spaces. So output section, is it eating up the white space? Yes, it is. Eating up the white space. Name plus, and then white space, and then it should see machine, name, colon, trailer. If I get rid of the trailer, this might give me some clues. Does that parses. So for some reason the word end after this is not header. And if I say end, so here I'm just playing. If I put end here, it fails. So that needs white spaces. Yes. So we could put the white space here. And that parses. So now we should be able to say header trailer with white space, eating end, machine. white space there. And now it succeeds. So we're getting the beginning and the end of the machine. So now we're going to try to define a state. State off. So so now we're going to add states here. A state definition is the keyword state followed by a name followed by a colon followed by some amount of white space. No problem. And in that, I've already forgotten what, so we're looking at this. So entry, so we're going to try to put entry code in here. Entry, A, B, C, D, E, F, we don't care. So a state is a state, a name, colon, white space, star, and then an entry section is the keyword entry followed by a colon followed by a string. White spaces are missing. White space star. What's wrong here? It's, where is it failing? It says that it got a state machine, which is a name section, an input section, an output section, and then a machine section. A machine section is a header, one or more states, and a trailer. And a state is state, the keyword state, and it's part of the keyword list, so that's okay. Followed by a name, followed by a colon, followed by some amount of white space, followed by an entry section. An entry section is entry followed by a colon, followed by white space, followed by more white space. No, still not. If I forget the string business, again, just testing away to see how much parses. That's fine. So the business about strings, something is wrong with my definition of strings. I'm looking at this definition of string down here. So it says a double quote followed by 0 or more string chars followed by another double quote. And a string char is an escaped character or any other string or any other character that isn't a double quote, basically. So an escape char is a it's not a it's a backslash followed by any character, and any string char is not a double quote followed by any character. So if there's a double quote, it'll fail here, and if it's not a double quote, it will succeed at this. And that's what we're getting here. Entry. So now if we put in a string A, B, C, C, D, E, F, it fails. Why? Oh, because there's white space problems. Where's the machine definition again? I've lost it. There, machine section, header, state plus, entry section. Nope. Something to do with entry colon white space followed by a double quote. What's going on here? State is state name there to there, followed by a colon, followed by 0 or more white spaces, followed by an entry section. An entry section is the keyword entry, followed by a colon, followed by a string, followed by 0 or more white spaces. Okay, so that was the error. I just forgot to put in this string here. So that appears to be working. We'll take that and we'll make a more interesting test. Now, the next test is entry. So now on the input, we will go to next off. So first we'll say on colon. 0 or more transitions. A transition is keyword on followed by the keyword followed by 0 or more white spaces. And there we go, white space stuck in there. So now we're going to put in a name in on white space, a name white space star. Take out that white space. Okay, there we go. So name needs white space at the front. Always, the way it's written. And then we're going to put in the keyword next, followed by next, followed by white spaces. So that worked. And now we need a name. Next goes to off. So we put a name here. Take out that white space. Name, followed by 0 or more white spaces. That's working. So now can we put in another state for on? Hang on, this is working fine. And we'll copy it into a new test here. That's still parsing fine, as it should be. That should have gone to on. And that's parsing fine. We get a name section, an input section, which is showing as inputs in, an output section, which is outputs no and yes, and then a machine section, which is all this other stuff. And now we're going to start actually putting code in here. We're going to call fire to the no pin. We're going to fire a true, and we're going to do the opposite here. Fire to the yes pin a true, and it's parsing fine. So as it stands, we now have a grammar. We could work on this grammar some more, or we can move forward. And what I'm going to do is just copy this grammar. Let's do it again. I'm going to copy this grammar, and I'm going to go back to this stuff, put the grammar in, get rid of all the old stuff. Put this at the front to make it JavaScripty. Get rid of that. So now we have grammar stuck in here, and now we need to escape all the backslashes. Replace string backslash with 2 backslashes, and there we go. It looks like it did it.